Okay, so let's talk about the answers and do a little review for our simple harmonic motion waves and sound test. What I'm going to go over are the answers to the questions that were on the quizzes review for today. So you will not see these questions in this particular order when you do the retake if you choose to do so. And I'm not going to write much on this screen, but I will express to you and explain to you some of the concepts. That first question there that I have cut and pasted is the greater the energy of a wave, the greater its amplitude. And that kind of makes sense. Think about a wave that is, draw one, a wave that is that big versus a wave that is that big. Well, a bigger wave means there's more energy to it, and that distance here from the resting position or from the equilibrium position is the amplitude. Now that second question, in a blank wave, the particles of the medium move perpendicular to the direction of wave motion. So wave is moving this way, but the particles are moving perpendicular to that. Well, that is a transverse wave. That's that traditional wave shape. And the medium is the material through which a wave transfers its energy. The effect of friction causing the motion of an object in simple harmonic motion to lose energy is called damping. Second question, is the Doppler effect, is the change in the frequency also the pitch due to the relative motion of either the sound producer or the sound observer or both? That third question, sound is transmitted by, and there were two choices here, but only one would spell out correctly in the fill in the blank for the quizzes, and that is compressional waves, also called longitudinal waves. Those two terms are synonymous with one another, and I made a very emphatic point about noting that to you when you took your notes. Now, the threshold of hearing is dependent on a couple different variables. One is the frequency. We can't hear all ranges of frequencies, only about 20 to 20,000 hertz. But the threshold of hearing is also dependent on the intensity or the energy or the loudness of the sound. Because just because a sound is 1,000 hertz and it's in our range, doesn't mean I can hear it unless there's enough energy or if it's loud enough for me to hear it. So the restoring force of a pendulum is zero. Where I got a pendulum and it swings this way and it swings over here. The restoring force is caused by the weight of the pendulum pulling it down. Well, if I had my pendulum just hanging there and I didn't pull it back, it wouldn't move because there is no restoring force. There is no weight force that will pull it down to that position. Well, what is this position called? That's the equilibrium position. And at that point, the restoring force is zero. Now, where a wave passes from one medium to another is called a boundary. When sound is going through air and then it goes into water or goes into glass, like you're talking through a window, it changes medium, so it changes its characteristics. That point where that change takes place from energy from a wave goes from one medium into another is called a boundary. Sounds that have frequency of greater than 20,000 hertz are said to be ultrasonic. The unit of frequency is the hertz. The distortion of sound caused by multiple reflections that meet at the observer at different times is called a reverberation. It is not an echo. Reverberation is when you get multiple reflections that meet at different times, so you don't hear a nice, crisp, clean sound. Acoustics is the study of sound, and the blank. A measure of a sound is a measure of its energy, or how loud the sound is perceived to be, is its intensity. The frequency of a wave is how many waves crests pass in a given amount of time, usually each second. So if we think about a wave like this versus a wave like that, you're getting fewer waves passing per second here. That's what frequency is. On a standing wave, The point where there is no motion of the medium is called a node. The time it takes for an object in simple harmonic motion to complete one full oscillation, start all the way to maximum displacement and back again, is called the period. The lowest point on a transverse wave is called a trough. So this point down here is called the trough, as opposed to the crest, which is up there. The blank of a sound is a description of the sound's quality. Now, this is a subjective term. It's not as much a physics term, but it is determined by some physics characteristics, like pitch, intensity, and how regular the vibrations are happening. That is called the tone of the sound. When something is vibrating, like a string or a column of air in a musical instrument, it sets up a series of standing waves. And the simplest one is called the fundamental frequency. But the more complex ones that are set up after that are called harmonics. The first harmonic is also called the fundamental frequency. It is the simplest waveform that can be set up. If you think about a stringed instrument, got my guitar string and it's between 2 points. It's held down here, held down here. Those would be like my nodes of my standing wave, and it vibrates back and forth. And it flip-flops back and forth like that. That would be representative of my fundamental frequency. It is the simplest vibration pattern that I can set up. And it's equal to about half a wavelength. This next question, the wave that is traveling outward. So in my guitar string, I pluck it and my wave energy goes this way before it gets to the other end and it comes back. Well, the outgoing wave from wherever the energy was inputted is called the incident wave, as opposed to the reflected wave, which is the one that bounces off and comes back. The mass at the end of the pendulum is called a bob. Now we'll get to some true or false of concept questions. Any person has the ability to hear any sound between 20,000 hertz and 20,000 hertz. That is decidedly false, because it's not just the frequency that determines what you can hear. It's also the intensity or the energy. Just because it's in our hearing range doesn't necessarily mean you hear it. It has to be loud enough or have high enough intensity. Gases emit sound faster due to a higher density. That is false. Gases actually transmit sound energy slower because they have a lower density because their particles are so spread out. And you have to wait for that molecule to go and travel to the next one and transfer energy and so forth and so on. The period of a pendulum is dependent on 3 variables: the length, the mass, the bob, and gravity. That is false. The mass of the object at the end of the pendulum has no impact on how long it takes to complete one oscillation. A spring with a higher spring constant will have a shorter period than one with a lower spring constant. And I said, think about the formula. So T equals 2 pi square root of M over K. So we're saying here, if we make this number bigger, if we make that number bigger, what's going to happen? Well, this quantity here is going to get smaller. So my period would get smaller. So a spring with a higher spring constant will have a shorter period than one with a lower spring constant. That is true. And you can tell that from the mathematical relationship you see in the formula. True or false? A reflected wave will have a lower amplitude than its incident wave. That is true, because when a wave hits a boundary, it always transmits some of its energy into the new medium. So it always comes back with less energy, hence a lower amplitude than what it did going out. True or false? Increasing the tension in the guitar string would raise the pitch of the sound produced. That is very definitely true. If you think about a guitar string, we hold it down here and hold it down here. And if I make the guitar string tighter, let's say I can pull the guitar string like that initially, and it can waver back and forth over that amplitude. So it gets going back and forth. Well, if I tighten the guitar string and now I can only pull it this far, well, it can't swing out as far, which means it has to swing back and forth more often, and therefore will have a higher frequency. True or false, a 40 dB sound is twice as loud as a 20 dB sound. That is false because the decibel scale is not linear. It is logarithmic or exponential. As the mass of a pendulum bob increases, the period decreases. So once again, oh, wait a minute. The mass doesn't have any effect on the period of a pendulum, because remember, period for a pendulum is 2 pi square root. Doesn't matter what you hang at the end. What determines the period of a pendulum is how long it is and what the gravity is in whatever location it's in simple harmonic motion. All right, so a mass oscillating in a spring would have a shorter period if the spring constant was higher. That was a repeat question. The speed of sound is very dependent on the density of the medium. That is true, because the closer together the particles are, the quicker they're going to transmit their energy. Think about those particles versus these. Well, how tightly together the particles are packed, that is what density is. So the more dense the material is, the faster it's going to transmit sound. The period and the frequency are inversely related. That is very much true. Frequency is 1 over the period. Period is 1 over the frequency. Finally, the second harmonic has a frequency that is double the fundamental frequency. That is true, because remember, harmonics are multiples of the frequency of whatever the simplest one is. So the third harmonic has a frequency that is 3 times and 4 times and so forth and so on. So you may choose to take the quizzes again, and you can take as many times as you need to soak up this information and practice in order to get 100.